Hello, everyone. Thanks for joining this talk. I'm glad to be here at the Ray Summit 2020. Unfortunately, we cannot meet in person today due to the pandemic. I hope everyone is staying safe. First, let me introduce myself a little bit. My name is Hao Chen. I'm a committer in the Ray community and a staff engineer at Financial. At the end, my team works on the recall. We support other teams to build systems on top of Ray. Ant is probably one of the earliest companies that started using Ray. We started with our collaboration with the Red Lab on Ray back in 2017. And during the past 3 years, we have widely adopted Ray in production for many business areas. And we also implemented a lot of systems on top of Ray. At the same time, we also want to contribute back to the open source community. We have open sourced a lot of features and improvements to Ray. And today I'm going to talk about two features, Java API and cross-language programming. They were just released a few days ago with the Ray 1.0. First, I'm going to talk about the Java API. So in the beginning, I want to explain why we needed Java on Ray. So as we know, the mission of Ray is to provide a fast and simple framework for people to develop distributed systems. Speaking of distributed systems, there are some popular areas. For example, in the machine learning area, Python is the most popular language, while in the big data area, Java is more common. And so we wanted to extend the Ray scope from only machine learning to also big data, as well as many other areas, and make it a general purpose framework for any distributed systems. And before diving into the details, let's take a moment to refresh our mind on the two basic concepts in Ray. So first, we have the task. The task is a task is a stateless unit for computation, and the Ray can turn any Python function into a task. So it's also called a remote function. And the other concept is the actor. An actor is a stateful unit for computation, and Ray can create an actor from any Python class. And here is one example. And then when we started designing the Java API, we thought about a few principles that we should follow. For example, we wanted the Java API to be still based on the two basic concepts in Ray, the task and the actor. And also, we wanted the Java API to be as consistent with Python as possible. And also, we wanted the API to be idiomatic to the Java language. So Java users who are not familiar with Ray can easily get started. And then let's take a look at how the Java API looks like exactly. We'll start from the task API. Here we have an example here. First we have a regular Java static method here. It's a square method in a math class. And similar with Python, we can turn any Java static method into a Ray task with this API, Ray.task.remote. And we can see there are two arguments here. The first one is the method reference to the square method, and the second one is an integer, which is the original argument of the square method. And by doing this, Ray will create a task in the background in a remote process. And at the same time, this API will return immediately with an object graph object. An object graph is like a future It represents a reference to a task results in race object store, in race distributed object store, and we can get the actual data of the object ref from this object ref.get method. Okay, then here we have an example for using actors in Ray. First, we still have a regular Java class here. It's a cont'd class with a increment method. Now we want to create an actor from this class. We use this read.actor.remote function, and this API takes one argument, that is the constructor of the cont'd class, and also this API will return an act handle object. Now we have this act handle. We want to call the increment methods on the cont'd actor, and then we just do cont'd.task.remote, and still we pass in two arguments, the method reference to the increment method and the original argument of the increment method. And then this method, this API also returns an object ref as the return type. And here we can see from here we just use a few lines of code to write a distributed counter in Java with Ray. And also we can set some options for a task or an actor. For example, here we set the resources for this task, and here we set the name and some other attributes for this actor. We use Fluent style API to do this. Another unique feature about Java is type safety. We know, unlike Python, Java is a strong typed language. This gives us the benefit of finding bugs before actually running the code. So in Rich Java API, we also wanted to leverage this advantage. You might have already noticed from the previous example that we have a few generic types here. The actor, handle, and the object ref types are all generic types. And what does this mean? For example, if we want to invoke an actor task with this API, the first argument here must be a method in the counter class, because the generic type of the act handle is counter. The second argument is more interesting. It can not only be an integer, which is the original argument of the increment method. It can also be an object ref of integer. And if we pass in the object ref as the parameter, we actually pass the reference of the first task result to the second task. And this will chain two tasks together. And we will only run the second task when the first task finishes. And besides the two basic concepts, the Java API also supports many advanced features, including actor tolerance, concurrent actor calls, killing tasks and actors, object reference counting, placement group, and there are many other examples here. Basically, everything in Python is supported in Java as well. And lastly, let's see how to use Ray in your Java projects. It's very simple. So first, we add this Maven dependency in your pom.xml file, and then we use the write.init API to initialize the Ray runtime in your process. And after that, you can start using Ray in your code. Okay, in the next section, I'm going to talk about I'm going to dive a little bit deeper into the implementation of the Java API. I will talk about how we implemented the Java API. So previously, when Ray only supported Python, we had the old architecture was very simple. On the front end, we have a Python worker here whose code is mostly written in Python. And on the back end, we had a few components, Redis, GCS, and object store, and the code and all the code is written in C++. When we started writing the first version of the Java front end, what we did is very simple. We just rewrote everything in Java. So apparently, there are some problems. So first, a lot of code and is duplicated here. We can see from this picture. And also, as we continuously add more features to Ray, it's hard to maintain a consistency between the two languages. And later, we made a re-architecture to fix these problems. And on the back end, everything is still written in C++. And on the front end, we introduced a new layer, which is called the core worker. Core worker is written in C++, and it contains the majority of functionalities in the on the worker side. And above of the core worker, we implemented the two thin wrappers for Python and Java to provide Python and Java API for users. The wrappers are very thin. They only contain some language-specific logic. And we use Python and JNI binding to connect them with the core worker. And this new architecture has brought us a number of benefits. For example, it helped improve the code quality for us, and it guarantees better consistency of behavior in Python and Java API. And moreover, it makes it easier for us to implement more advanced features on the worker side. If you take a look at today's code base, you will find a lot of complex features are implemented in the core worker. For example, we implemented the worker-to-worker direct transports in order to improve the performance. And we implemented an in-memory object store in order to reduce the overheads of the distributed object store. And we've also implemented reference counting for the distributed objects to improve race memory management. And last but not least, another benefit is that it makes it easier for us to support new languages in Ray in the future. In the last section, I'm going to talk about another feature that is coming in Ray 1.0, and that is the cross-language programming. First, let me explain why we need this feature. As we know, the distributed systems are getting more and more complex today, and sometimes we need to write different components in one single system in different languages. For example, an online machine learning system usually consists of 3 parts. The first one is a stream data processing module, which is written in Java. And in the middle, we have a model training module, which is usually written in Python. And at the end, we have a model serving module, which is sometimes written in Java, sometimes written in Python, depending on a company's tech stack. And however, here comes the problem. Traditionally, we use GRPC to do that, but that's not easy. Let's see from this example what we need to do to develop the most naive Python to Java hello world program with gRPC. First, we need to define a proto file here. we have the definitions for the service and the request and the reply messages. And then we need to implement the code for the Python client and the Java server. Due to the size of the slide, the Java actor, the Java example is not complete, but we can see from the example that how much code is needed. And after that, we still need to deploy the server somewhere and use a service discovery tool to help the client find the service, the server. And also, if we have complex data structures, we need to convert the data into protobuf format when sending a request. And when receiving a request, we also need to convert the data back from protobuf format to our own data structure. So we can see here, even for the most simple, the simplest hello world program, it's not easy. The amount of work is significant. And then let's see how we can solve these problems. So first, we have let's say we want to implement the same hello world program with Ray. First, on the Java side, we have a greater class here. It has only one method called say hello. It's very simple. It's like an ordinary Java class. And on the Python side, we can create an actor based on the greater class by using the read.java actor class .remote function, and we pass in the package name and the class name of the greater class. And by doing this, we will automatically create a Java actor in a remote Java process. And similar to the previous example, this API also returns an actor handle. We name it greater actor here. And then we have this actor handle. We can do greater actor.sayhello to .remote. And by doing this, we will send a request from Python to Java, to the remote Java actor, and then invoke the say hello method and return the results back to Python again. And finally, we can use this read.get API to get the actual data of this message. So we can see, compared with the previous example, this one is much simpler and more natural. Right now, Ray supports calling actors and calling tasks, creating actors and calling actors in any combination between Java and Python. And another thing we implemented is data serialization. We want to make the experience more natural. So right now, you can pass some types directly between Java and Python without manually doing data serialization. For example, we support primitive types, including integers, doubles, bytes, strings, and so on. We also support lists and maps of primitive types, as well as actor handles. For example, here, we have a Java method here. These methods had 3 arguments: an integer, a string, and a list. And on the Python side, we also we want to call this Java methods, and we just need to simply pass an integer, a string, and a list to the Java methods. Under the hood, we will automatically handle the serialization and the deserialization stuff for us. And another cool feature we have implemented is called cross-language exceptions. What does this mean? So for example, if you call a task in a different language and an exception occurs, we will chain the exception stacks together for you. So for example, let's say we have a Java task calling a Python task, and the Python task is calling another Java task, and something wrong happened happens in the second Java task. And Ray will show you an exception stack like this. We can see at the top of the exception stack, we can find the Java exception information from the first Java stack. And in the middle, we can see the Python exception stack from the Python task. And at the bottom, we can find the Java exception stack from the second Java task. And here we can also find the root cause of this exception chain, which is divided by 0 exception in Java. So with this feature, we can easily debug a cross-language program. Okay, lastly, let's take a look at what we have talked about today. So we introduced 2 new features that are coming in Ray 1.0. First, we talked about the Java API, which allows you to build distributed Java systems easily with Ray. And also, we talked about the cross-language programming feature, which allows you to seamlessly build cross-language applications with Ray. And also, we talked about how we use the C++ coworker to resolve the problems in Ray's worker architecture. If you want to know more about these 2 features, please visit the documentation website. And if you have more feedbacks about these features, please join the Java channel on Slack or file an issue on GitHub. That will be very much appreciated. And okay, all right, thanks. And that's everything. Hope you enjoy this talk. Thank you.